Skybird, this is Dropkick with a red dash alpha message in 2 parts. Break, break.
Hello YouTube. Going to do a somewhat thorough video on how to make a spirograph with using most likely green and red laser. What you're going to need, first off, you need motors with mirrors. This is probably the trickiest one. If you want a decent effect and a decent beam, you got to get first surface. And if you use a regular mirror, you're going to get artifacts of extra 2 dots, typically off of one reflection. So you'll have a strong dot and then weak dots. So I'm using the motor out of a DVD drive. It's the tray motor, and I left the pulley on the back, like you see on this one. And I epoxied the first surface mirror, found the center, and then just gave it a slight tilt. It has to have a bit of a tilt or you don't get an effect, right? The idea of the spirograph is bouncing the laser off one mirror that's rotating, then off another, and you can even do a third and a fourth. You can get really technical with these, and it gets more interesting the more motors that you add. So we're just going to be using 2 on this. The chip we're going to use to control the motor speed is 2 transistors, the BD437, and these regulate current as long as the voltage is steady. So they're not technically constant current, but they do regulate the current to the motor. And with the 10K trimmer, potentiometer, whichever one you want to call it, and a knob. I've got one set up already here, and we're going to put all that into a hobby box. So I'm going to go with these this fancy perf board here. I picked these up for a couple of bucks each at the local surplus. And we're going to mount our transistors on it. And we're also going to mount both of our motors with mirrors. So it's going to get a bit tricky. Have to figure out where we're going to put our mirrors. It's going to be something along the lines of this. So we're going to have to mount our circuit along the back wall here. There's not much to it. There's only a couple of components, just the transistors and I think 1 resistor. And that's it. And your leads in and your leads out and your leads to your trimmer. Actually 2 trimmers. 2 transistors, 2 motors, 2 trimmers. Okay, so this is the negative rail here, if you can see. Okay, it's got a couple of rails on it. for positive, negative, or what have you, a common connection. So I'm going to solder the motors negative onto the rail here. You got to be careful with these perf boards not to heat them too much or the trace peels right off. So I put a lot of solder paste just to make sure it goes down nice and fast. Okay, so I think we're all buttoned up here, with the exception of course, mounting the mirrors and the motors. So I'm looking at something along the lines of this. I'm going to use these old plastic lens nuts. You can use any type of spacer just to bring up the motor enough that the corner of the mirror doesn't catch. You can use smaller mirrors. These are about an inch square. You can use smaller, but then you don't have as much wiggle room to get those beams to line up or to hit both mirrors. Because when this one moves, it's going to be dancing. So you got to get it kind of close, but not too close to smash your mirrors. All that fun stuff. Anyway, so you got to make sure that your motor can spin freely, right? So I'm using these, which are probably about just a little more than 1/4 of an inch, or raising it off the board here. So I'm just going to hot glue this into place and then epoxy it after. I'm not using any special hardware to mount this. Well, let's wipe these plastic mounts first. Make sure you get a good clean surface. I did this to the board without recording it, but you get the idea. Make sure everything's nice and clean. Into your motors. These things are quite old, so they've probably got a layer of who knows what oxide on it. And on the back side, on the clean part, I'm going to give the mirror a little clean up. Well, that's about as good a surface you need for this type of application. It's fairly clean. Okay, let's go ahead and check our dimensions here before we go any further, which will be mounting whichever color laser. I got to make another one of these, so I'm not going to go crazy on the laser yet because I want to come do a combination. For my daughter, I'm going to do a red, blue, and combine them into a pink beam. You need red and blue to make pink. So for my son, I'm thinking green and blue because he likes teals and green. So we'll see which way we're going with that. Okay, so everything looks to fit. It's going to be a little wobbly, probably vibrate a bit because it's not mounted yet. I'm still going to put a nice blob of hot glue under each corner, maybe the center of the board, set that down in there, and then put a little bit on top to keep it secure. There's nice ridges on the inside of these project boxes, so it gives the glue something to hang on to. And then I'm also going to be installing some rubber feet on it because this thing will probably dance across the table. Not maybe here because this is soft, but you put it on a regular coffee table or something, it's probably going to move around just a bit. See, it's already moving ever so slightly by itself. Well, that's also the wire pulling on it. If I move this up, that should stop. Oh, it's not bad. It's not vibrating too crazy. Turn these up. You can hear it a bit because it's not anchored yet. When you anchor it, you're still going to have that buzzing. That's at full speed, of course. So the additional hot glue will take care of that. Again, you mount with screws with something like this, and you're going to have more of a rigid connection between all the parts, and you don't want that because then the outside case is going to do all the shaking, whereas some of this is lost on the inside. So our mirrors are spinning up just fine. Our exit's going to be somewhere around here, but we're not going to cut it. The trick with any type of laser project you put together, wherever you have an output beam, don't guess it and start cutting holes. Rather, what you want to do is, I'm going to lift these up. There's a little platform I'm supposed to sit on. Get everything put together first. That's number one. You get everything set, your laser glued in place. You don't want to change things around afterwards. Like, I want to add another beam to these. I want to add 2. So I've got limited space to do it because on this side it's going to be the battery. I'm going to make this a single cell lithium ion that'll power both the motors and the lasers, or laser, whichever. And I'm going to do it with a floating charge circuit, so you can plug it in, leave it plugged in, and the battery will stay not fully topped up, say around 3.9 volts, and that way you can just unplug it and the kids can play with it in the backyard, on the side of the house, or whichever, on larger surfaces. But so I need this room that's already back here. That's where my battery is going to go. Once everything is secure and done, then what I'll do is I'll take a piece of white paper and slip it in here in front of where the beam output is, and I'll turn it on, and then I'll get a general idea of how much of a circle I need to cut in here. And as the laser is running, I'll use that circle to trace out, but the beam output's so close, its spread should only be about 1/4 of an inch, so we'll make the hole about 1/2 inch, or just enough to accommodate that output. And then we'll put a piece of glass on the inside and glue it in place and seal it so no dust can get in through the hole. But we're not going to cut that hole until absolute last, because you want everything in its position. So you turn it on, play around with it, see how everything works out. Because this is a blue case, if you do this with a red laser, for me I'm using a blue clear transparent-ish case. Red laser, if you're only working with a 5 milliwatt red laser, what's going to happen is this blue is going to absorb that. Laser goggles for red lasers is blue, so this blue plastic is going to absorb a good amount of that beam, and might make it tricky to do the cutout for it, but I'll figure this out. Anyways, so that's it. We're almost there. Okay, so I'm consulting my bag of DPSS green lasers. These are 532 nanometer, 50 milliwatt. Mode shifting. It seems to be a nice, fairly clean beam, with the exception of a little bit of circular artifact on it, but that's probably just because it's been sitting for so long. Oh, let's see here. It gets tricky holding all this stuff. Alrighty, so we've got that on the wall. Let's back that down. Alright, so now we're at 115 milliamp draw at 4.2 volts. Get this clip back in here. I'm going to dim that out a bit, give you a better idea. So that is a little more the speed that I wanted at. And we're setting it by the little trimmer. Okay, so we're going to go with my bag of handy dandy parts here. These are just old plastic acrylic lenses that come with diode mounts. You end up collecting a bunch of these because I always use glass optics and metal nuts and all that fun stuff. So these have actually come out to be perfect little spacers for something like this. So might as well get you some use out of those. And I end up putting 2 onto a single lens, 2 focus knobs, 1 lens, and just make a spacer out of it. And it threads together nicely. And this way here you got 2 nice even spacers with a lot of surface. There's a lot of surface area for the glue to attach to. So we're going to go with these 2 guys right around here. So it's going to be the same thing as the motor mounts. So actually going to have to cut a big chunk off the front of this thing. And we got some glue on the mirror. Of course. I hope that's not a crack. No, it's not a crack, it's glue. It's little strings of hot glue. I need a razor to take that off without getting fingerprints all over the place. This glue is very stubborn on such a clean surface. It's one of those little fine threads of glue. And that's going to be a bit of a problem. That's okay, I'll get that off with some alcohol after. For the time being, let's get this dialed in, our position, so I can glue this into place. I got one more of these things to make. Again, we're going to come in on a slight angle by the looks of it. There's no perfect science to this. That should be, it's going to be coming out roughly in the middle. You know, watch that the beam doesn't collide with the other mirror once it hits the first and then hits the second. Alright, so I'm going to glue them in that position there. Do them one at a time. Get some into the bottom of this. And we're going to set that down in that same position. It should be squishing nicely out the bottom by now. And do the same for this guy. And get it all squeezed through. Prime up the back of this one, make sure it's all filled in with glue. And drop that guy into place on that slight diagonal position to make sure the beam enters at the right angle, so it's not coming out the top of the spirograph. Let that harden up a bit. I've got some glue squished out the bottom. Just smear it around a little bit, just make sure it's got a good footing. These will not come off. Not unless you try to take them off, and the way that's seated in there, chances are if you try to take these off, you'll break the board. So there shouldn't be any problem with strength there. These are going to be as strong as the board is. Same goes for the motors, but with the motors I'm going to put a lap of glue over the top and down to the bottom. You really gum it up with some glue. Okay, so it seems to have dried nicely. I don't know if you can see the angle. It's on a slight upward angle, pointed towards the first mirror. So I'm just going to lift that just a hair, and we're going to get some glue underneath this one. And I might actually shut the laser off because that's adding a lot of heat to the system, so it's going to dim that laser right out. Green lasers like to operate at a lukewarm temperature. Too cold and it drops the output, and too hot it drops the output. So when you're working with hot glue and a green laser, be prepared for it to flash out on you, possibly. This one seems to be doing okay. We've got our final output position here. Our hole is going to have to be about 1 inch in diameter on the box to accommodate this beam. As you can see on my hand, see, it's about 1 inch right at the wall. So we're going to have to cut that size to accommodate the beam, or it's going to get clipped on the output hole. Okay, so there's our single beam. I just noticed something. This camera does not like green. I don't know what color that's showing up as on your screen, but on my computer monitor, it's showing up as a almost a white. Very strange. So let's see our time tunnel effect. I'll get that a little closer. That's more like it. So we can speed that one up. Again, I still gotta make a slight adjustment here. No, that's not gonna work. That's the other guy. Should be numbering these. So that should give us a proper time zone. Let's try this again. That's more like it. Again, the green isn't really showing up well. It looks a little more green there, but it's still not showing up very well. And then when we activate the second, we get some funky stuff going on. I gotta be careful not to strike the lens too much, because I turned up the laser just a little bit to get it brighter. Okay, so here's a close-up of the finished product. Well, not quite finished, but you get the idea. So everything seems to be operating fine. Transistors are getting hot. Again, it's only a few milliamps. I think these motors run at like 10 or 15 milliamps each at most. One issue, this is why you don't permanently glue. As you can see, the edge of the crystal blue case. So look at where our beam output. You can see it's slightly clipping the top, which when you put the lid on is going to be a problem. That's one issue. It was awfully close to this post here, which I can't cut. I can, but you're taking away support from the lid. I could actually put this upside down. I could attach this board to the lid and then drop the box on top of it, which is probably what I'll end up doing. So this is actually upside down right now. But just to give an idea, so there's some final adjustments to be made to make sure that output window is of an appropriate size and doesn't conflict with the structure, being the edges and stuff. I don't know, my camera keeps doing this, but anyways, so that's it. It's as simple as a spirograph gets. Again, I'll be doing one in the near future that's a little more complex. 3 or 4 motors and mirrors, sound activation, and 3 color, well, three laser, 3 primaries, red, green, and blue, and you'll be able to adjust that and get a white beam, yellow, pink, all the different colors in between. So that's it. That's straightforward. I hope the videos were too long. I'm going to go through and edit and speed up the boring spots, and hopefully it all comes out to a way that helps you build one of these and isn't too long-winded. So thanks for watching, guys. Be sure to subscribe, throw a like if you can, and click that little bell, or whatever it is you have to do on YouTube now to get notifications, everything changing. And I'll see you on the next one.